Today, we'll be looking at the history of artificial intelligence, from the beginnings to the most recent breakthroughs. If you're new to this channel, welcome, where we explore the scientific and technological breakthroughs shaping the future as we know it. It is often beneficial to examine our history in order to predict the future. We'll revisit the brief history of computers and artificial intelligence to see what the future holds. The fact that even relatively new computer technology feels ancient to us now demonstrates how quickly the world has changed. In the 1990s, mobile phones were large bricks with tiny green displays. 2 decades ago, punch cards were the primary form of computer storage. Computers progressed so swiftly and became such a vital part of our daily lives in such a short period of time that it is easy to forget how new this technology is. The timeline shows that the first digital computers didn't come out until about 80 years ago. Some computer scientists have worked since the beginning of time to create machines that are as intelligent as humans. The following timeline depicts and describes some of the most important artificial intelligence systems. The first system I'd like to discuss was called Theseus. It was created in 1950 by Claude Shannon and was a remote-controlled mouse that could find its way out of a labyrinth and remember its path. Artificial intelligence has come a long way in the last 7 decades. AI systems' language and image recognition abilities are now comparable to those of humans. By zooming in on the last 2 decades of AI research, the figure demonstrates how we got here. The plotted data comes from a series of studies that looked at how well humans as well as AI did in 5 different categories, from reading handwriting to understanding language. The initial performance of the AI system in each of the 5 domains is set to -100, and the performance of humans in these tests is used as a baseline and is set to 0. This means that when the model's performance surpasses the 0 line, the AI system receives more points than the people who took the identical test. Only 10 years ago, no machine could reliably perform human-level language or image recognition. But as the graph shows, AI systems have been getting better and better and are now better than humans in all of these fields. The performance of these AIs are mixed outside of these standardized tests. In some real-world scenarios, computer technologies continue to outperform humans. On the other hand, certain AI implementations are already so low cost that they can be found on the phone in your pocket. Image recognition categorizes your images, and speech recognition transcribes what you say. Image recognition to image creation. The previous graph demonstrated the rapid advancements in artificial intelligence's perceptual powers. The AI systems have also improved their ability to generate visuals. This 9-image series depicts the evolution over the last 9 years. None of the people in these photographs are real. They were all created by an artificial intelligence system. The series begins in the top left corner with a 2014 image of a pixelated face in black and white. As the first image in the second row demonstrates, just 3 years later, AI systems were able to generate visuals that were difficult to distinguish from photographs. AI systems' capabilities have grown even more amazing in recent years. Early systems focused on making images of faces, but these newer ones have added the ability to make images from text in response to almost any question. The image at the bottom right demonstrates that even the most difficult prompts, such as a Pomeranian sits on the king's throne wearing a crown, 2 tiger soldiers stand next to the throne, are instantly transformed into lifelike graphics. Language recognition and production are rapidly evolving. The graphic depicts instances from the Palm artificial intelligence system developed by Google. The system was asked to explain 6 different jokes in these 6 samples. The explanation in the bottom right is especially impressive, as it's an anti-joke that is meant to trick the listener. In recent years, systems that can create language have made their way into our society in many different ways. Emails are auto-completed, huge amounts of internet content are translated, films are automatically transcribed, school children use language models to do their homework, reports are written automatically, and media outlets publish AI-generated journalism. Where we are now, the age of artificial intelligence has arrived. These rapid developments in AI capabilities have enabled robots to be used in a wide range of new domains. When you book a flight, it is generally an artificial intelligence, not a human, that determines how much you spend. When you arrive at the airport, an AI system tracks what you do there. Once on board, an AI system assists the pilot in navigating you to your destination. Artificial intelligence algorithms are also increasingly determining whether you obtain a loan, qualify for welfare, or get hired for a specific job. They are increasingly influencing who is freed from prison. Several governments are buying self-driving weaponry systems for conflict, while others are deploying systems for monitoring their citizens and enforcing state tyranny. AI systems aid in the programming of software and the translation of documents. Over the last decade, many households have welcomed virtual assistants powered by speech recognition. Self-driving cars are finally becoming a reality. In recent years, AI systems have aided in the advancement of some of science's most difficult problems. Large AI algorithms known as recommender systems determine what you see on social media, which things are offered to you in online stores, and what you view on YouTube. They are increasingly not only recommending the material we consume, but actually generating it based on their ability to generate visuals and texts. Artificial intelligence is no longer a technology of the future, it is here, and much of what is currently reality would have appeared sci-fi only a few years ago. It is a technology that already affects all of us, and the list above only scratches the surface of its numerous applications. The vast range of mentioned uses demonstrates that this is a fairly general technology that individuals can employ for some incredibly good or bad goals. It is critical for such dual-use technologies that we all have an awareness of what is happening and how we want the technology to be used. The world was quite different just 2 decades ago. What might future AI technology be capable of? What comes next? The AI systems we just talked about are the result of AI technology getting better and better over many years. The large chart shown here puts this history in context over the last 8 decades. In this chart, each small circle represents one AI system. The circle's position on the horizontal axis shows when the AI system was built, and its position on the vertical axis shows how many computers were used to train that particular AI system. Flop or floating point operations are used to measure training computation. A flop is the addition, subtraction, multiplication, or division of 2 decimal values. All AI systems that use machine learning need to be trained, and training computation is one of the 3 key components that determine what the system can do. The other 2 components are the algorithms and the training input data. The picture shows how AI systems have become more powerful as the amount of training data has grown. The chronology begins in the 1940s at the dawn of electronic computers. The first AI system to be shown is Theseus, which is Claude Shannon's robotic mouse from 1950. AI systems like DALL-E and Palm, which can make lifelike visuals as well as interpret and generate words, can be found towards the other end of the timeline. They are among the AI systems whose training has used the most computing power so far. The computation for training is shown on a logarithmic scale, with each grid line representing a 100-fold gain. This long-term perspective indicates a steady increase. For the first 6 decades, training computation grew in lockstep with Moore's law, nearly doubling every 20 months. Since about 2010, this exponential growth has gotten even faster, taking only about 6 months to double. That is an incredible rate of growth. The rapid doubling times have resulted in significant increases. Palm's training computation was 2.5 billion petaflop, which was more than 5 million times greater than AlexNet, the AI with the biggest training computation just 10 years ago. Scale-up was already exponential and has accelerated significantly during the last decade. What can we learn about the future of AI from this historical development? AI researchers examine long-term trends to determine what is conceivable in the future. One of the most talked about studies of this kind was written by AI researcher Ajaya Kotra. She looked into the increase in training computation to find out when the amount of computation needed to train an AI system might be the same as that of the human brain. At this stage, the system is expected to match the capabilities of a human brain. In her most recent update, Kotra said that there is a 50% chance that transformative AI will be made by 2040, which is less than 20 years from now. Such an AI system would be powerful enough to bring the globe into a qualitatively different future. It could cause a change as big as the agricultural and industrial revolutions, which were the last 2 big changes in human history. It would undoubtedly be the most significant worldwide change in our lifetimes. In this case, Kotra's study is especially important because she based her prediction on the same type of long-term trend in training computation that we just looked at. But it's important to note that other forecasters who use different factors come to pretty much the same conclusions. As I showed in the earlier timelines, many scientists think that human-level artificial intelligence will be made in the next few decades, and some even think it will be made much sooner. Creating a public resource to facilitate the required public conversation. Our world has changed a lot because of computers and artificial intelligence, but this change is still in its early stages. Because this technology is so ubiquitous, it is easy to forget that all of the technologies with which we interact are relatively new, and that the most dramatic changes are yet to come. Artificial intelligence has already altered our perceptions, knowledge, and actions, despite the fact that this technology has only been around for a short time. There are no indicators that these trends will stop anytime soon. On the contrary, basic trends have sped up, especially in the last 10 years. Investments in AI technology have grown quickly, and the time it takes to double the number of training computations has dropped to just 6 months. Every big technical innovation has both positive and negative implications. This already applies to artificial intelligence. We should expect the impact of this technology to grow as it becomes more powerful. Because of the significance of AI, we should all be able to express an opinion on where this technology is headed and how it is affecting our environment. We are still in the early stages of this history, and much of what will become feasible is still ahead of us. Technical advancement of this magnitude should command our full attention. Little may be more essential for how our world and our lives will unfold in the future. What's your take on this? Let me know down in the comments below and check out one of these other videos.